Hello, this video is for IXL Activity A1.D.4. It is titled Percent of Change, and the 3-character code for this activity is Golf Romeo Golf. So our question is, what is the percent of change from 200,000 to 90,000? And then we're given 4 different choices, a possible increase or decrease. Now, if we go from 200,000 to 90,000, we realize that the number's getting smaller, right? Lesser value, so we know it's a decrease, so we can rule out the increase. The question is, how do we know which one of these decreases are the correct answer? Well, there is a formula for percent of change problems, and it has to do with original amounts and new amounts. So you have an original amount, such as 200,000, and then you have a new amount, which is 90,000. So you're starting with an original amount, and you're going to a new amount. And I'm going to use the notation you'll see over here on the left where I have OA, I'm going to call the original amount, and NA, I'm going to refer to that as the new amount. So what is that formula? Well, it's a fraction, so we're going to have a fraction bar. And in the numerator, we're going to take the absolute value of the original amount and subtract from that the value of the new amount. And then we're going to divide it by the value of the original amount. So in this case, let's go ahead and apply that here. And if we're talking about the absolute value of the original amount, so the original amount is 200,000. So we have 200,000. We're going to subtract from that the new amount, right? The value of the new amount is 90,000. And then, again, we need the absolute value sign. And then we're going to have the value of the original amount here. And I guess the original amount, I need to actually put that in there, is 200,000. So in this case, 200,000 minus 90,000 should be what? 110,000. So absolute value of 110,000 over the original amount of 200,000. And so what's the absolute value of 110,000? Well, that's 110,000. So I'll go ahead and bring that over there and bring my 200,000 over. Now, if I go ahead and divide that out, and I put 110,000, 1, 2, 3, 110,000, I want to divide that by 200,000. That's going to give me a value of 0.55. And if I write this as a percentage, I'm going to move that decimal over 2 places, throw a percent sign on the end, and 55%, and it is a decrease because we have a lesser amount, so it's going to be 55% decrease. Now, if it were an increase, we would end up with a negative number. And I guess let's just go ahead and look at a problem there where we have that situation. So what is the percent of change from 5 to 8? So it is an increase. So we can rule out the decreases here, right? So the question is it 60% or 6%? So remember, it is the absolute value of the original amount minus the new amount over the value of the original amount. So let's go ahead and plug that in. So absolute value of original amount is 5 minus the new amount, which is 8. And the original amount is 5. We're starting with 5, going to 8. So now 5 minus 8 is negative 3 over 5. Now the absolute value of negative 3 is positive 3 over 5. And 3 divided by 5, 3 divided by 5 is going to give us 0.6. Make that a percentage, move the decimal over 2 places, we get 60%. So it's 60% increase in this case. Now, if you wanted to, instead of dealing with the absolute value, we could just realize, okay, to get a positive number, we're going to have to divide or subtract the lesser value from the greater value. So if I would have just looked at this and said, okay, 8's greater than 5. 8 minus 5 is 3. What's the original amount? The original amount is 5, and that would have got me to this step right here at 3/5 already. And I could have kind of skipped the whole concept of the original value. We'll do some more of that later on. So percent of decrease from 30.5 to 0. So the original amount is 30.5. This is the original amount. And the new amount is 0. So, no, not the word no, the word NA for new amount. So let's take the absolute value of the original amount, 30 minus 5, and we're going to subtract from that 0. And our original amount is 30.5. Now, 30.5 minus 0 is going to be 30.5 over the original amount, 30.5. And the absolute value of 30.5 is 30.5. And bring that 30.5 over from the denominator. And any number over itself equals 1. Now to make this a percentage, move the decimal over 2 places. Have to throw a couple zeros in there. And 1 is going to work out to be 100%. So it is a 100% decrease. Now you probably could have figured this out without actually plugging all that in. Because if you're starting with some value and going all the way to 0, how much have you lost, or how much is it decreased by? It's decreased by the entire amount. 100% of the original amount is what the decrease is. So you probably could have gone from 30.5 to 0 and realized that that is a decrease of 100%. On the next one, what is the percent of increase from 7 to 7? Well, it doesn't change at all, right? So you'd think, okay, it's not going up, it's not going down, so it's 0. It has a 0% increase or decrease. Now, if we go ahead and put that in, if we call this the original amount and this the new amount, absolute value of 7 minus 7 over the original value of 7. 7 minus 7 is 0. The absolute value of 0 is 0. And 0 divided by anything is 0. So this would be 0%. What is the percent of decrease from 75 to 51? So this is the original amount, and this is the new amount. So let's go ahead and go absolute value of 75 minus 51. And our original amount is 75. So this is going to give me the absolute value of the difference of 75 and 51 is 24. So absolute value of 24 over 75. Now the next step is take the absolute value of 24, which is 24 over 75. Now I need to take this ratio, this 24 over 75. Every fraction is a division problem, so I'm going to do 24 divided by 75, and that's going to give me 0.32. So let's go move that decimal over 2 places and throw a percent sign on the end, and we end up with a 32% decrease in this case because the value got lesser. What's the percent of increase from 400,000 to 600,000? Well, on this one here, this is the original amount. This is one of those ones that I was talking about that we could say, okay, I'm going to take the greater value and subtract the lesser value to get my numerator and then divide by the original amount. So we'll do that after we look at the actual applying the numbers to the actual formula. So the absolute value of the original amount is 400,000. And we're going to subtract from that the value of the new amount. And this has to be the absolute value of that. So we have those absolute value signs. The original amount is 400,000. Now let's go ahead and do the subtraction here. 400,000 minus 600,000 is a negative 200,000. And that's over 400,000. And now the absolute value of negative 200,000 is positive 200,000. Divide that by 400,000. We can tell this is 1/2, right? So we know that would be 0.5. Move the decimal over 2 places, and we would get 50%. Now, if you didn't want to deal with the absolute value concept, you'd realize, okay, which is the greater of the two numbers? 600,000 is greater than 400,000. So let's subtract the lesser value from the greater value, and we would have ended up with 200,000. and then divide by the original amount, 400,000. And now we're at the same spot that we're at this point, and we realize it would be 50%. What is the percent of decrease from 400,000 to 30,000? So let's go ahead and apply that concept of greater minus lesser. So let's just do the 400,000 minus 30,000. So 400,000 minus 30,000. And we're going to divide that by the original amount, which the original amount is 400,000. Now 400,000 minus 30,000 is going to give me what, 330,000? Right? No, it's not. It's going to give me 370,000. 370,000. Just to double check that. I am positive of that one. 400,000. 3 minus 30,000 is 370,000. Indeed it is. We're going to divide that by the original amount, 400,000. And we do 370,000. We're going to divide that by 400,000. And we're going to get an answer of 0.925. Let's move the decimal over 2 places. We would get 92.5. Throw the percent sign on the end. So the answer is 92.5% decrease. What is the percent of increase from 29.5 to 88.5? Well, 88.5 is greater than 29.5. So let's go ahead and do 88.5, and we're going to subtract from that 29.5, and that's going to give us 0, and 88 minus 29. 88 minus 30 would be 58. Throw 1 back on 59, I believe. I could double check it. 9 and 9 is 18. Carry the 1. 5, 7, 8. Yep, indeed it is. So it's going to give me 59. I'm going to divide that by the original amount, which is 29.5. Whenever I do that on my calculator, 59 divided by 29.5, that's going to give me an answer of 2. Well, 2 is a percent. Move the decimal over 2 places. Actually, let me go ahead and move that there. The decimal would be here, right? Move the decimal over 2 places. Need to throw a couple zeros on there, so we would end up with 200% would be our answer. Is a 200% increase. Does that seem about right? So I should be able to multiply 29.5 times 3, 88.5. Indeed it is. Okay. So next one, what is the percent of decrease from 300,000 to 100,000? So let's go back to that using the absolute value concept. So this is our original amount. This is our new amount. So the absolute value of 300,000 minus the new amount, which is 100,000. Always good to kind of remember what the formula is. Shortcuts are really nice sometimes, but it's nice to remember what the formulas are. So put our original amount there as the denominator. 300,000 minus 100,000, that's going to give me an absolute value of 200,000 over 300,000. And now the absolute value of 200,000 is indeed 200,000. And we're going to divide that by the original amount, which is 300,000, which is the same as 2 divided by 3. That's going to give me 0.666. It's just going to be a repeating 6. Okay. They want us to round our answer to the nearest tenth. So if I move my decimal over 2 places, I would get 66.66%. Now they want me to round it to the nearest tenth of a percent. So the tenths place is right here to the right of the decimal. So look to the right. The 6 here is going to make this 6 become a 7. So we'd have 66.7%. That would be rounded to the nearest tenth of a percent. Don't forget to put the percent sign on there. Final question. What is the percent of increase from 20.6 to 81.8? So let's go ahead and do that. And we'll go ahead and keep it. This would be a good time to show how the absolute value concept kind of comes into play. So original amount, new amount. So let's do the absolute value of 20.6 minus 81.8. And that's going to be over our original amount, which is 20.6. Now let's go ahead and subtract that 20.6. 20.6 minus 81.8. And I'm going to get a value of negative 61.2. And I'm going to put that over the original amount, 20.6. Now, if I would have done 81.8 and subtract from that 20.6, I would have got a positive 61.2. So either way, we come up with the same thing because the absolute value of negative 61.2 is going to be a positive 61.2. So the value inside the absolute value sign, if it's negative, it becomes positive. If it's positive, it stays positive. So a little bit of review on absolute value there. Little footnote, absolute value is all about the distance from zero. And negative 61.2 is just as far from zero on a number line as a positive 61.2. So that's what absolute value is all about. It's all about the distance of a number from zero on a number line. So let's go ahead and bring our original amount of 20.6 over. Now let's do our 61.2. We're going to divide that by 20.6. And that's going to give us a value of 200. I'm sorry, I'm getting ahead of myself. 2.97087, etc. So if I move the decimal over two places, 1, 2, I'd end up with 297.087%. Now it wants us to round to the nearest tenth, so that's this position here to the right of the one place to the right of the decimal is the position of the tenths place. So we look to the right. So this 8 is 5 or more. So we're going to raise the score. That means that the 8 is going to make the 0 become a 1. So we're at 297.1%. 297.1%. So it's nearly about 3 times as much. And this case, let's see. Okay, I paused it. I had to check my thought process there. I was thinking 3 times the amount, but actually it would be close to 4 times the amount because 297.1% is almost 300%, which means that would be almost 4 times as much. So 20.6 times 4 would be what? 6, 12, 24, like 82.4, I think. And it's 81.8, which is just below that. So that seems to make sense. So this answer here indeed makes sense. It's always good to double check and ask yourself, does this answer make sense? And indeed, for me, this does make sense. So those are all of my examples for IXL Activity A1.D.4 Percent of Change, and good luck with your activity.